All right, we're going to talk about something now called the intermediate value theorem. And I suppose back in the days prior to graphing calculators, this intermediate value theorem may have had more purpose than it does now. And it may have a purpose in much higher level math than what we're going to consider. But it seems, well, we're just going to address it and then just move on. And basically what the intermediate value theorem says is that if a function is continuous, and we've got a value of x that is on the graph, that other values of x will also be on the graph because the value is continuous. Now there's a corollary to that, which is called the location principle. And basically what it is saying there is that, again, if the function is continuous and the graph crosses the x-axis, we should be able to determine from a table that at what point the graph is going to, what interval, between which interval or which integers the graph is going to cross that x-axis. And we can determine that from the table where we see between two values, or where x is we're looking at two values of x, and what the y values are, the f of x is. If the signs change, if we see opposite signs, then we know that between those two integers, the graph is going to cross the x-axis. So that's about all I can say about that for right now, but we're going to look at a couple of examples. Okay, so like I said, this intermediate value theorem makes my head hurt, but basically what it's saying is if you got a continuous function and we see that the function crosses the x-axis at somewhere between an interval value here and an interval value here, we're going to see that the y values, or f of x, for any given value of x, f of x is going to change signs. And somewhere between that point, those 2 points where f of x changes signs, is going to be a 0. We can say that that's going to be a 0, or we might say that it's a root. It'll be something else that we'll talk as we go along, of the function, which is basically meaning this is where it crosses the x-axis. Okay, we'll look at a couple of examples. All right, so here I got this function. I got f of x equals x squared minus 6 over x plus 4. And I'm being asked for an interval between an interval of -3 and 4. By the way, I'm on the bottom of page 27, guided practice. This is example 3. Does the graph cross the x-axis, and if so, about where does that happen? So here I've graphed this function here, x squared minus 6 over x plus 4. And I can see, at least in this portion of the graph, which is this is continuous. Obviously, I got a point of discontinuity somewhere out here, but it's not asking me about that. And I can see that this graph does, in fact, cross the x-axis. Looks like somewhere between -3 and -2, and then comes back in over here between 2 and 3. Looks like it crosses the x-axis again, but I've been asked, okay, in this interval, -3, 4, where do I see that cross? And I can go over here to my table, and what I'm looking for is at what points between which values of x do I see the signs change for the y values, or the f of x values. And I can see that, hey, definitely here between this -3 and -2, it's definitely going to cross the x-axis, because the sign changes. And then looking down here, oh, okay, I see right here that also between 2 and 3, signs change, means it's crossing the x-axis. Go figure. Okay, so I'm still at the bottom of page 27. Determine between which consecutive integers the real zeros of each function are located on the given interval. And so I'm given this. I've got f of x equals 8x cubed minus 2x squared minus 5x minus 1, and it's asking us, is there anything between the interval minus 5 and 0 where we see any sign change? So here I've got the function graphed, and I can see kind of right there, I kind of covered it up, it kind of looked like the graph kind of bounced off the x-axis, and I can definitely see that it's crossing the x-axis here. But if you look, the interval that it's asking me for is this interval minus 5. Let's see, 1, 2, 3, 4. An interval right here to 0. Is there any place where it crosses the x-axis? And all I could really see when I looked at that, and I'm going to go ahead and just erase this function here, is that it looked like that it bounces right there between what they're asking me for in this interval minus 5 and 0. Well, I come down here into my table, and the only place, I mean, I've got to really drill it down to see where I begin to see the sign change. And I see right here, if x is equal to minus 3/4, y is equal to minus 1.75, and if x is equal to minus 1/2, well, we do see a sign change here. We see it go to 0, okay? And then if x is minus 0.1, I see that we go back into negative territory. So it did, in fact, bounce right there off of the x-axis. But I'm being asked to try to define between which integers do I see a sign change. And all these others right here, well, these other values right here are rational numbers. Didn't ask me that. Asked me between which integers. Really a screwball question. And so between the interval minus 5 and 0, then I could say that between minus 1 and 0, consecutive integers, asking me which consecutive integers, I do see a sign change in all this mess right here, and I'm done.